In the Picaxe system, there are a number of different kinds of symbols or variables that we can make use of. This presentation will cover those different types and how to correctly choose. Alright, with a bit, which is one type that we can use, we can have either a 0 or a 1, and it consists of just then one bit. So we're only using one bit when we're dealing with a bit. The possible values, because this bit can be either a 0 or a 1, would be a total of two different values, those values ranging from a 0 to a 1. Now if I were to take and put 8 bits together, I would get a byte. So I could say, for an example, have 0, 1, 1, 0, that's 4, 5, 6, 7, 8. I would have a total of 8 bits now. That would form a byte, any combinations of ones and zeros. And I would now have a total of 256 different possible combinations. That would give me values that range from 0 to 255. Now I can also take these bytes and combine them. So let's say I have something like 5, 6, 7, 8. So here's one byte, and I combine them with another byte. 3, 1, 2, 3, 4, 5, 6, 7, 8. There's my mark there. There's 5, 3, 4, 5, 6, 7, 8. There's my other one. So here's a byte of 1. There's another byte. This becomes what we refer to as a word. So word is made up a total of 16 bits, which gives us a total of 65,536 different combinations of ones and zeros, which for us then ranges from 0 to 65,535 is the maximum value. So we then have a bit, doesn't take up very much memory, but can only store two different values, 0 or 1. Byte takes up more memory, 8 times as much, and we can then store a larger value. We can take and use a word, which takes up even more memory, and we're able to store even larger values. Now what we have to watch is that we do not overlap or inadvertently use those different spaces. For example, if I have a symbol with the pickaxe, and let's just call it test, and I've set it equal to byte 0, that's a specific location in the pickaxe memory, that's going to use 8 bits someplace. I can also have a symbol, let's call it test 2, and we can make it a word sized symbol or variable. Now the problem that can arise from this is that B0 is made up of 8 bits. B1 is a byte size storage location made up of 8 bits. Well, those two form W0. So byte 0 is half of W0. Byte 1 is the other half of W0. So if you have a symbol, as I have here, called test, that's B0, any change to this is going to influence W0. Any change to a B1 is going to change W0. Any change to W0 may change one or both of these. So you've got to watch that you correctly allocate your memory to your symbols so you're not inadvertently changing your other symbols or variables. Now sometimes you do this intentionally, but you got to watch it you don't do it inadvertently. And likewise is true that B0 and B1 are made up of bits as well as W0, and we have to watch that if we are using something like bit 0, that's a part of B0, that we're not inadvertently changing some bytes and then as well some words. So you got to very carefully choose your different locations for storing your symbol variable information.